When you hold two magnets together, North Pole facing North Pole, and feel that invisible resistance pushing back through empty space, you think you're asking a simple question. Why do they repel? But you're not asking what you think you're asking. Your question is fundamentally flawed, and until you grasp why it is flawed, every answer you receive will leave you unsatisfied. Let me reveal the actual problem here. Take those two magnets, position them north to north, feel that force, that mysterious push happening in what appears to be nothing but air. You're expecting me to say something like, magnets repel for the same reason that, and then provide you with something comfortable. Springs stretching, rubber bands pulling two palms pressing against each other. Something that already makes sense to you. Here is what you need to hear. No such familiar comparison exists. This isn't me being deliberately obtuse or hiding behind scientific jargon. This is the uncomfortable truth most people refuse to accept. Magnetic forces are fundamental forces. They're at the absolute bottom of the chain. There is nothing beneath them to use as a reference point. You're demanding I explain electromagnetism by referencing something more elementary. But nothing more elementary exists. It is equivalent to asking me to explain basic arithmetic using concepts simpler than numbers themselves. It is impossible. Right now you're thinking, hold on, I've definitely heard explanations before. Magnetic fields, spinning electrons. Those seem like deeper answers. They're not. They're descriptions. Incredibly precise, experimentally verified descriptions. They tell you how the force operates, not why it fundamentally exists. Understanding this distinction is critical, or we're just wasting each other's time. Let me pose a question to you. Press your palm down on your desk surface right now. Press firmly. Why doesn't your hand penetrate straight through? You'll likely respond because the desk is solid. Incorrect, not incorrect, because the desk lacks solidity. It certainly has it. But incorrect because you're just relabeling the phenomenon you're trying to comprehend. Try once more. Why can't your hand pass through? Because atoms are densely packed, getting warmer. Continue. Why don't the atoms comprising your hand pass through the atoms comprising the desk? Because atoms themselves are solid. No, stop right there. Consider this carefully. Atoms are not solid objects. An atom consists mostly of empty space. If you expanded an atom to football stadium dimensions, the nucleus would be a pea at the center. The electrons would be tiny specks way out near the seating area. Everything between is emptiness. Your hand is fundamentally empty space. The desk is fundamentally empty space. So why don't they interpenetrate? You're getting uncomfortable now. Excellent, you should be. The answer is electromagnetic repulsion between electrons. The electrons in your hand and the electrons in the desk carry identical charges, like charges repel each other. So when you press downward, you're experiencing trillions upon trillions of tiny electromagnetic interactions, collectively creating what you perceive as solidity. Now here is the question that'll really disturb you. Why do like charges repel? You cannot answer that, can you? You might say electromagnetic force, but that is merely naming it. That is not explaining anything whatsoever. It is like responding, why do magnets repel? Because of magnetic force. That is circular reasoning. That is meaningless. The electromagnetic force is one of four fundamental forces in our universe. It is not produced by something else. It is not derived from something more basic. It simply exists. And here is what nobody bothers telling you. The force preventing your hand from passing through the desk surface. That is precisely the same force making magnets push apart. The exact same force, not similar, not comparable, identical in nature. The electromagnetic force. So why does one seem obvious while the other seems mysterious? I'll tell you exactly why. You've been pushing against solid objects since you were 6 months old by age 2. your brain had accumulated an enormous database of experiences. Pushing, grasping, falling, hitting surfaces. Your neural pathways wired themselves around these experiences. They constructed patterns, expectations, an entire intuitive framework. So now, when you push against a desk, it feels normal, natural, self-evident. You don't question it. You don't think it requires explanation, but magnets. Magnets push through visible empty space. You can observe the gap. You can insert paper through it. There is nothing visible there. That feels strange. That feels incorrect. That feels like it demands an explanation. But here is the reality. The strangeness exists in your perception, not in the physics. When you push against the desk, the electrons in your hand never actually make contact with the electrons in the desk. They repel across a distance, a microscopic distance, a few atomic widths, but still a distance. We label it contact because the distance is imperceptible, but it is not genuine contact. Nothing is touching. It is electromagnetic repulsion operating across a gap. With magnets, the gap is larger, a centimeter, an inch, large enough to observe, large enough to trigger discomfort. But the force is identical. The mechanism is identical. The only difference is the scale. The mystery you perceive is not a mystery in the physics. It is a mystery in your psychology. You're comfortable with electromagnetic repulsion at atomic scales because you've experienced it throughout your entire life. You're uncomfortable with electromagnetic repulsion at centimeter scales because it is less familiar. That is all. That is the entire difference. Now you're probably thinking, all right, fine. But surely quantum mechanics explains why the electromagnetic force exists. Wrong again. Quantum electrodynamics, the quantum theory of electromagnetism, is the most precisely validated theory in all of science. We've measured certain predictions to 11 decimal places, and the theory matches perfectly. But here is what QED actually does. It tells you how to calculate electromagnetic interactions with ridiculous precision. It provides you with rules, equations, predictive capability. What it does not do is tell you why the electromagnetic force exists in some profound philosophical sense. It describes the force beautifully, perfectly, but it doesn't explain it away. It doesn't reduce it to something simpler, because nothing simpler exists. Let me demonstrate this with a different example. You ask, why does ice float on water? I can tell you because ice is less dense than liquid water. Why is it less dense? Because the molecular structure has more space between molecules. Why does it have that structure? Because of how hydrogen bonds arrange themselves at freezing temperatures. Why do hydrogen bonds arrange that way? Because of the quantum mechanical properties of electrons in water molecules. Why do electrons have those properties? Because of the Schwarzschild-Feidinger equation and the Pauli exclusion principle. Why do those equations hold? See what is happening. At each step, I'm providing you a deeper answer, but I'm also just pushing the question backward one level. Eventually, and this happens quickly, you hit bedrock, the fundamental equations, the basic forces, and there. The only honest answer is, that is what we observe. That is what the universe does. We can describe it mathematically. We can test it experimentally. We can use it to generate predictions and construct technology. But we cannot explain it in terms of something more fundamental, because nothing more fundamental exists. The chain of why must terminate somewhere. Here is the profound problem with your question about magnets. When you ask why, you're not genuinely asking for information. You're asking for comfort. You're asking me to connect the unfamiliar phenomenon to something familiar, so you can stop feeling confused. You want a narrative, a story, a chain of cause and effect that terminates with something you already comprehend. But magnets repel because of the electromagnetic force. And the electromagnetic force exists because that is a fundamental property of the universe. There is no narrative. There is no deeper because. There is just observation and mathematics. Now I understand that is not satisfying. I understand you want more, but the universe doesn't care what you want. The universe is what it is. Let me tell you what genuinely bothers me about this question. You're treating magnets like they're exceptional, like they're the one peculiar thing in a universe of normal things. That is backwards. Everything is electromagnetic if you examine it closely enough. Why do chemicals react? Electromagnetic forces, rearranging electrons. Why does light reflect off mirrors? Electromagnetic interaction. Why do you perceive colors? Electromagnetic radiation hitting your retina. Why does your computer function? Electromagnetic forces moving electrons through circuits. The electromagnetic force isn't some exotic phenomenon that only manifests in magnets. It is everywhere. It is the dominant force in your entire existence. Gravity weaker, by a factor of 10 to the 36th power, completely irrelevant for atoms and molecules. The strong and weak nuclear forces confined inside atomic nuclei. Too short, range to affect anything you can touch. Everything else, and I mean everything, is electromagnetism. The force making magnets push apart is the same force holding your body together right now, the same force preventing you from falling through your chair, the same force allowing you to read these words. So when you ask me to explain magnetic repulsion by comparing it to something normal, you're asking me to explain electromagnetism using electromagnetism. It is circular. It cannot be done. Let me try a different approach. Perhaps this will help. You know how you can explain the color blue to someone who can see. You show them the sky, a blue shirt, you provide examples. But how do you explain blue to someone blind from birth? You can discuss wavelengths, about 450 nanometers. You can describe where it sits between red and green in the spectrum. You can give them all the physics of blue, but none of that conveys the experience, the actual blueness of blue. They must see it. There is no shortcut. Same with magnets. Same with electromagnetism. You don't acquire the intuition from an analogy. You don't acquire it from a 5-minute explanation. You must work with the mathematics. You must solve problems, make calculations, predictions, test them. After months, perhaps years of working with electromagnetic theory, something shifts in your brain. The equations start to feel natural, intuitive, obvious, not because they match your everyday experience, but because you've constructed a new everyday experience, mathematical experience, familiarity with how fields behave, and then magnets aren't mysterious anymore. They're exactly what you'd expect, inevitable consequences of charged particles and fields. But you cannot shortcut that process. You cannot skip to the end. You must earn the intuition. Now let me tell you what I can provide you, the technical answer. Magnets possess magnetic dipole moments, little arrows of magnetism. When you align numerous them in the same direction, you get a permanent magnet. Those dipoles create a magnetic field configuration that stores potential energy. Physical systems naturally evolve toward lower energy states. When two north poles face each other, the energy is high. Moving them apart lowers the energy, so they repel. That is the answer. That is as deep as it goes. You want to know why dipoles create fields. I can tell you about moving charges and electrons spin. You want to know why electrons have spin. I can tell you about the Dirac equation and quantum mechanics. You want to know why the Dirac equation is correct? I can tell you it follows from combining special relativity with quantum mechanics. You want to know why those theories hold, because they match reality, because we've tested them millions of times and they work. That is it. That is where the chain terminates. Here is what you need to understand about how physics actually operates. We don't start with philosophy and derive the universe. We start with measurements. We observe patterns. We write equations that describe those patterns we test those equations against new experiments. When the equations work, when they allow us to predict things we haven't seen yet, we say we understand the phenomenon. Understanding in physics doesn't mean philosophical satisfaction. It doesn't mean matching your intuition. It means predictive power. It means being able to calculate, to predict, to construct technology that functions. By that standard, we understand electromagnetism better than almost anything. Quantum electrodynamics is tested to incredible precision. We can calculate the magnetic moment of an electron to 11 decimal places, and the measurement agrees exactly. So when I say I understand magnets, I mean this. I can calculate the force between them. I can predict how they'll behave in different configurations. I can design electric motors, generators, MRI machines. I can manipulate magnetic fields to trap particles or focus beams. That is genuine understanding. That is what physics offers. Not comfort, not familiar analogies, but power, control over nature. You might not like this answer. You might find it unsatisfying. Too bad. The universe doesn't owe you an explanation that makes you comfortable. It doesn't owe you a story that matches your intuition about how things should work. Your intuition evolved to throw rocks, gather fruit, and avoid predators on the African savanna. It did not evolve to understand quantum fields or electromagnetic interactions at the atomic scale. So when physics reveals something that violates your intuition, particles acting like waves, time slowing down at high speeds, magnets pushing through empty space, you have two choices. You can reject it as mysterious and unsatisfying and keep demanding better explanations that don't exist. Or you can expand your intuition, learn the mathematics, work through the problems, construct new mental models based on equations and experiments, not everyday experience. That is what physicists do. None of us found quantum mechanics intuitive at first, but we worked with it long enough that it became familiar, and eventually it started to feel natural. Not because it matches common sense, but because we constructed new common sense. Mathematical common sense. So here is what I want you to take away from this. The next time you pick up two magnets and feel them push apart, don't ask why. Ask how. How does the force depend on distance? How strong is it compared to gravity? How can I calculate it? How can I use it? Those questions have answers, good answers, precise answers, beautiful answers. The why question, the one asking for reduction to something more familiar. Not for magnets, not for any fundamental force, because fundamental means exactly that. Bottom level, nothing underneath. But here is the beautiful thing that people miss when they get stuck on why. What physics reveals is that the universe operates according to a small set of rules. The same equations that describe magnets also describe lightning, brain signals, computer chips, the aurora borealis, chemical bonds, why stars shine, why atoms are stable. That is not a failure to explain. That is unification. That is discovering that underneath all the apparent complexity and chaos of nature, there is a deep structure, a mathematical structure, simple rules with incredibly complex consequences. That is what should blow your mind. Not that we cannot reduce magnets to something simpler, but that we can reduce thousands of seemingly different phenomena to the same underlying force. You wanted me to explain magnets by comparing them to something familiar, but I'm telling you something better. Everything familiar is actually magnets, or rather, everything is electromagnetism. Same thing. Your desk, your body, the air, light, chemistry, life itself. It is all different arrangements of electromagnetic interactions. You're not separate from the magnets. You're made of the same force. So was my refusal to answer the BBC interviewer arrogant. No, it was honest. I could have given him a comfortable lie. Magnets are like springs, or think of magnetic fields as rubber sheets, or whatever would have made him nod and feel satisfied. And he would have learned nothing. Instead, I told him the truth. The question itself was broken. The kind of why he wanted doesn't exist. At the fundamental level, things simply are. And our job is to describe them accurately, not to reduce them to something more comfortable. People despised that answer, called it evasive, called it a failure to communicate. But they were wrong. Sometimes the most honest answer is, the universe doesn't work the way you expect. Your intuitions are incorrect. And if you want to understand what is really happening, you need to learn a new way of thinking. That is not arrogance. That is respect. Respect for the truth, respect for the actual structure of reality, and respect for you, for your capacity to handle that truth instead of needing a comfortable fiction. So pick up those magnets one more time. Feel that invisible push. Now understand, you're feeling one of the 4 fundamental forces of nature. The same force that makes chemistry work, the same force that makes stars shine, the same force holding you together right now. That is not mysterious. That is magnificent. And the fact that we can describe it with equations, test it with experiments, and use it to construct technology, that is not a failure to explain. That is what understanding actually looks like.